Hello, math and science lovers. This is James from Southern California. Today, I want to share a physics problem related to potential and kinetic energy and energy conversation. Okay, problem 27. 1 kilogram tetherball is suspended by a string 0.8 meter long from a nail at point X, uh, 0.5 meter vertically above a horizontal rod at Y. Uh, when the ball is released from Z on the same horizontal level as Y, it swings down and the string catches on Y. Okay, question A, what is the initial gravitational potential energy of the tetherball relative to point X? B, what is its initial potential energy relative to point Y? C, determine the location of points A, B, C, and where the mass has respectively. First, maximum kinetic energy. Second, maximum velocity. Third, maximum potential energy with respect to y after it's released. Calculate the value of each. Question D, how high above y must the tetherball be released so that it will swing completely around a circle of radius 0.3 meter about point y? Okay, let's do one by one. Question A, what is the initial potential energy relative to point y? We know initially it's at point z, which is 0.5 meter under x. So suppose its potential energy is negative. So A should be so P E. Let me say P here should equal to negative mgh. Okay, so negative m is 1. G, let's just simply take it as 10. So the height is 0.5. So that being said, it's negative 5 J. Okay, this is then B. What is its initial potential energy relative to point Y? So we know Y and Z at the same height. So suppose here PE negative mgh, as h is 0, so just 0. Okay, this is for A and B. Let me erase it. So C, determine the location. Yeah, I already draw. Suppose the ball fall down through the blue pathway, go to point A, B, which is the lowest place. Then this ball will do circulation motion around the rod at a place Y. Then finally, suppose it reach the place C. At place C, the velocity or speed go to 0 because all the kinetic energy will convert to potential energy. So to answer this, for I maximum kinetic energy happen at point A, and the B maximum velocity also help at point A or B. They are the same place. Okay, so let's talk about maximum kinetic energy. So we suppose the kinetic energy is converted from the potential energy. So suppose K equal to delta P equal to mg h suppose is delta h. Let me call it delta h. Yeah, anyway, m is 1, g is 10. Delta h here is 0.8 minus 0.5, so just 0.3. So we get 3 here. And maximum velocity. So suppose half mv square equal to k. So we can easily get v go to 6/1 square root. Yeah, if calculated, suppose it's yeah. Let me make sure. Yeah, we can take it as 2.45 meter per second. Okay, so let me write 2. This is the way. Okay, the third, maximum potential energy with respect to y after it's released. Yeah, we know the higher the height, the higher the potential energy. After released to y, after released, then suppose the ball will just go back to place C, which is at same height as the initial height at Z. So again, the maximum potential energy respect to y or relative to y, right? In past we use relative to y. Then suppose to answer this, the PE max. Yeah, let me write. Come on. Yeah, here means PE max. Again, just equal to 0. Means through 0 is not big, but it's bigger than negative potential energy. For example, at place A or B. Suppose if relative to point Y, it has negative potential energy. So in this kind of means, so at place C, they have bigger potential energy than point A or B. Okay. Yeah, let me scratch over this. Okay, now let's go to the last question. How high above y must be the tether ball be released so that it will swing completely around a circle of radius 0.3 meter above point y? Yeah, this is a good question. Don't forget at point y, at point D, yeah, the ball cannot have zero velocity, because if in this way, suppose the ball will fall down vertically, like this way. Come on, like fall down this way instead of go circulation motion. Yeah, so let's suppose at this place, the ball has a speed v prime. Then the minimum of v prime to let the ball at least do the circulation motion. That being said, we have at this place the gravity will be its will generate the acceleration to guarantee the circulation motion. So we have F equal to mg equal to m v prime square over r. Okay, that means that we can get v. Here we don't need v prime. Yeah, anyway, v prime should equal to g r square root. That means that go to, for example, 10 times 0.3. So it's about 1.7. Okay. That being said, the ball should starting from a place higher than the place D. Yeah, for example, if place D is, oh, come on, is about at this height, then the ball should go to some place even higher. Yeah, for example, like here, which is about how high above here. Yeah, let's set this as, how about H prime? Okay, then suppose we have H prime mg H prime equal to half m v prime square. That being said, mgh. Yeah, that being said, H prime should equal to v prime square to g. Yeah, as we know just now, v prime square equal to 3. So here is 20. So that being said, it's about 0.15 meter. Okay. That being said, the place, if we call this place is E, E should be E. The place is 0.5 minus 0.3 minus 0.15 0.05 meter under X. Okay, that's all for this problem. Thank you for watching. If you feel interested, you can subscribe my channel to learn more.